Sometimes it's useful for us, instead of finding actual solutions, to just be able to determine the type of solutions. It tells us a lot about the graph, about what type of solutions we're going to end up with, and it also sometimes helps us decide whether we should factor or use the quadratic formula. And that process is called using the discriminant. The first thing you have to do, though, in order to use the discriminant is make sure that your equation is equal to 0. So I'm going to take the -7 and add it to the left side and get 1. Once I do that, I can determine that the first 4 is my A value, the second 4 is B, and the 1 is C. And the discriminant is b squared minus 4ac. It's the part that's underneath the square root in the quadratic formula but doesn't actually include the square root. So if I set up my discriminant, I have 4 squared minus 4 times 4 times 1. And I'm going to get 16 here when I square, and also 16 here, so 16 minus 16 is 0. And what that tells me is that is the part underneath the square root, and I can actually take the square root of 0. So I know that I'm going to end up with a real solution. And since 0 is a perfect square, it's also going to be a rational solution. And when I do take the square root, if I'm thinking about the quadratic formula, I have negative b plus or minus, the square root of 0 is just 0 all over 2a. And the point is that when I take a number and I add and subtract 0, I'm going to get the same value both times. A number plus 0 and a number minus 0 are the same thing. When I divide by 2a, I'm going to get one solution that's repeated, but it is one real rational solution. If my discriminant had come out to be a negative number, you would have 2 imaginary solutions. If it was a positive number, there would be 2 real solutions, and you would have to determine whether they're rational or irrational based off of whether it's a perfect square or not a perfect square.